Okay, so we are going to do measures of variation. Last time we did measures of center. So if it is variation, what kind of variation are we talking about? Variation of what? Variation of statistics. Well, when we did measures of center, it was the center of what? The type, right? Same thing. Measures of variation simply measure the variation in the type. Start with something simple. If I had a bunch of numbers, let's say, three different data sets, for example, as how much variation does the first sample have? None. Why so?
They're all the same.
They're all the same, right? There is no variation among constants, all the same number. So obviously 0. Data set 2 and data set 3. Which one has greater variation? 3. Why?
The numbers are more scattered.
The numbers are more scattered. Emery used the word scattered. That's pretty much what we're trying to do. How spread out are the observations on the real number line? If you grab those points and put it on the real number line, they're going to be very close to 2. And if you try to put those, there is 1 here by 2, or a bunch of by 2, 200, 124, 512, 5,000, whole lot of variation. So we just have to come up with a statistic that's going to measure this variation in the data. So we'll just do a top one to be easy. No. There's 5 points, right? And if I asked you, well, I need some sort of a numerical quantity or statistic that would measure the spread of those data points, what would you say? What would that number be? Something that will measure how far these observations are spread apart.
Wouldn't it just be 1?
1. Where'd you get 1 from?
Well, I mean, because 1.5 to 2.5 is 1, and most of them are in between 1.5 and 2.5.
Okay, what's your name?
Talent.
Tyler kind of has a point, but kind of wrong too. So his way of thinking was, okay, most of them are right here, and 1.5 to 2.5, it has to be 1, right? But do you see observations there? Do you see observations there? So whatever value that you computed is going to have error. Do you agree? You're overestimating. So what else is better? Go with Tyler's thought process.
That's the point, like 1.5 to 2, there's 0.5, that's 0.7.
1.5 to 2.
So you could say like it's 1.8, 1.9, and then 2, and then it can be 2.1, 2.2, 2.3.
Okay, so somewhere here to there. Okay, getting closer. Lily got closer. So here to there. Instead of guessing, I want to make use of the task. So what would you do? You're closer than Tyler. Nick.
Just do the largest minus the smallest.
Take the largest minus the smallest. Yours would work too, but yours is going to have some error also. But I can simply do the largest value minus the smallest value. I'll know the spread of those observations, right? And that is what we call the range. Maximum value minus the minimum value. That's it. That will be the range of data. Is range a good measure of spread? In other words, it sort of worked out nicely here, but is it very reliable?
If there's outliers, no.
Exactly. If there are outliers, the range is not going to be a good measure of variation, just like mid-range from last time. Measures of center. If you have an outlier, then the mean, the median, the mode, they're going to be way off. So if I have an outlier, for instance, if I accidentally wrote 179 instead of 1.79, that variation would be huge. But in reality, 4 observations are close to 2, right? So you would be making an error. So we wanted something different, and that's where variance comes into play. In terms of rotation, there are 2. So sigma squared, which is population variance. S squared, which would be the sample variance. Both of them have, formulas. I'm going to let you guys use a calculator because we want to be working smart, not hard in this class. Understanding is key in this class. So what does variance do?
What is the first symbol?
Oh, sideways 6. Sigma, sigma squared. I call it the sideways 6 or drunken 6. 6 not drunken. So we are going to primarily deal with sample variance. We have sample, we're going to get variance, and I'll show you how to do that with the calculator. But how does it measure deviation or spread? Let's say we have a bunch of observations, arbitrary ones. Bunch of observations. Good. Of course, I could say 8 minus 2 range, that's the spread. That will work. It'll work for this particular example because there aren't any outliers. If I asked you, where would the average lie? Would you say it would lie here? Where? There? Right. Somewhere over here. So I'm just going to arbitrarily draw a line. The way variance is calculated is to find something called the deviation. we're going to use the calculator and get the answer, but you have to understand as to what it means. So on both sides, we're simply going to measure how far each observation is from the center. Right, those are called deviations. And if I took the average of all these deviations, it should give us the spread between the two, correct? So I've measured from here to there, here to there, here to there. So the average should give us, you know, a measure of spread. But the problem is, when we mathematically do it, you will see that this deviation will negate that deviation in somehow, in some manner, and eventually you end up getting an answer that's very, very close to zero, right? Is the spread zero for that data? Clearly not. So the spread is not zero, but if I simply added the deviations, I'll end up getting zero. So to avoid that, we would simply square each of those deviations and get the answer. Does that make sense? So this is the formula. I'm sure the book has it. And it's the sample size. Sideways M means sum. X of I would mean each of those observations. You don't have to memorize this formula. I'm putting it here so that you don't get confused if you see this formula when doing homework. We're going to make use of a calculator. Be very smart. So what this formula says is we're going to take each value of X, which would be those, subtract the mean. In other words, I'm finding the deviation, how far each observation is from the deviation, excuse me, from the mean. And I said we have to square it so that we don't get the zero, so I'm squaring it. And I also mentioned it has to be an average, so I'm going to divide by n minus 1. You may ask me, well, average simply means divided by n. Why did you put n minus 1? Well, that gets into advanced statistics. I'm not going to go there. This is the formula for sample variance. Population variance is pretty much the same. The denominator here is n. So the formula will be the same. The difference here is it's just n. So there is a reason why that is the case. We won't get in there. But do you understand the concept? Each observation minus the mean, square the deviation, divide by n minus 1 for theoretical reasons. That will give you the sample variance. Here you have the population variance. Good. Whatever number that we find, if we take the square root of it, we will end up getting the standard deviation. This can be done using the calculator also. Here is a question. Could that variance be ever negative? Why not? Come again? Well, true, but my question, you're kind of going backwards. My question is, could that be negative? Why not?
Because like even without the square, you'd be dividing by a positive number.
So close to him. He keeps getting closer and closer, but he said even without the square. That's not true. It is the square which makes it positive. Right? So all of those numbers are positive because of the square. The sample size is always positive, so the variance is a positive quantity. When you do the homework, you end up getting a negative variance. It means you made a mistake somewhere. Good. It cannot be negative. As Emery mentioned, square root of a negative number doesn't make sense here, so it has to be positive. Good. So the standard deviation is a better measure of finding spread. This is the meaning behind it. And that would be the formula. And I'm sure that the book would work out step by step. What are you supposed to do? Instead of using the formula, choose calculator. Good.